understand how to use it. So today we are going to be studying Desmos, and this is very simple, but it's also going to be important. So let's get started. So the main thing you want to know with Desmos is that there are a few functions. Let's take x for example. Right here. X. X creates a single line. So this can expand to infinity. And so the calculator and the graphing isn't very distinct on this. It's just a straight line. But this is probably the most normal singular line you get. Because if we add a variable, a constant in front of it, like 2x, our single line shifts a bit. And that's because our line is getting into a more chordless. Its shape is changing as we grow the factor constant. So if we put 3, 4, 5, 6, 7, 8, whatever, it will gracefully grow from that starting position. So that's x. Next, we got x squared. X squared. X squared. It's very interesting, satisfying doing this. But this is what we call a quadratic function. And the quadratic function goes to infinity positively. But we can also make it go to negative infinity. Negatively. And I think quadratic functions are a very viable test that they're going to teach you on the SAT. So make sure to grasp that concept down. Let me give you an example. On the SAT, it might give you something like x plus 4 and x minus 5. And we have a quadratic function because this is essentially saying x squared plus 4x minus 4x, sorry. This is basically saying, x squared minus 5x plus 4x minus 20. That's basically what this is written out right here. Because if we factor this out, we get this value. And you know that's true because the red and the blue line are the same exact thing. So that's how we know that these two are equivalent. So yeah, that's exponentials. That's quadratics. Next, we got exponentials. Now, exponentials, in my opinion, is quite easy to test on the SAT because exponential functions are very simply written, and if you understand the concepts, they're not hard. But let's say we have any constant, 13 for example, and we raise it to, and we decrease it. Let's decrease this one to 0.76 to the power of x. We get an exponential function. This graph is stating that this is going from positive infinity all the way down to this small number, but it's never touching this. So this plateau is seepingly onto this value, 0, but it will never reach 0 totally. It will never, well, in this case it did, but usually it never reaches 0 at all. So that's what exponential function is. We also have something that is an important factor. You can do something called table. This is an important thing, but you can put in points on a graph. Just put random points, I don't know. And then you glass display right here. This is actually an important, but a magnifying glass to find the zoom fit. Or you can write a linear regression that matches it. And this right here gives you a slope intercept form for this, but you could change this to a cubic regression. You can change this to a quadratic regression. You could change this to a power regression. You can literally change it to whatever you want, and you can change it to some of these corrections a sign. But that's besides the point. Next, we got regression models. Now, regression is still something I kind of struggle with, I'm not going to lie. But let's say we have x. We have f of x is equal to x squared plus 3y minus, let's say x squared plus 3, x squared plus 6, 6x minus 8. Let's say this was our regression model. And then we'll say plus 9, for example. We'll say this, right? We can treat this as a regression if we put f of x 1, is regression x squared. We can put a 1 on the bottom plus 6x to the 1 to get a regression model. And in this case, there's no constant, but if there's a constant, you would have to use the regression model to figure out a constant. So this is a regression. It's telling you the parameters of a particular solution. So it's a very useful test in the SAT. So next, we really don't have much, but let's say you're given a percentage of a solution. You can literally write 13% of 87. These are also some important factors, but this can also be written as a fraction. You can write, if you're given a percentage problem, you can write 7. Let's say we're given 13 is 13% of P. We don't know P, but we can say 13% of P is 25. How will we write this equation as a percentage point? So first we gotta figure out what the question is asking us. It's asking that 13% of P is 25. So 25 is the P value. 13% of 25. Wait, let me read this again, sorry. 13% of P is 25. So it's basically asking us is that what percent of P of 25 is 13%. So that's how you can read this. But we could just say that it could be 13 divided by 25. We could write it as that. I think I read this wrong.